Welcome everyone. We are discussing integration of trigonometric function. Today, through this video, I will solve some typical problem of integration of trigonometric function. Look, problem number 1. Sin x plus cos x root over sin 2x dx. Sin x minus cos x root over sin x into cos x dx. Root over tan x plus root over cot x, root over tan x minus root over cot x, root over cot x and root over tan x. So, only 1 and 2. If you solve 1 and 2, then these are special cases of 1 and 2. So, number 1, sin x plus cos x by root over sin 2x. So, we want to put a transformation so that we get sin x plus cos x. So, what is the transformation? Derivative of sin x minus cos x equals to z. Why we are putting this transformation? Because if we differentiate it, we get numerator. And this sin 2x is expressible in terms of sin x minus cos x. Look at how. So, derivative is cos x plus sin x into dx equals to dz. So, we are getting numerator. But in denominator, sin 2x is not present. So, look, if we make calculation, if we take square, 1 minus sin square x cos square x, this is 1, minus 2 sin x cos x. Or you can write cos square x plus sin square x minus 2 sin x cos x equals to z square. So 1 minus sin 2x equals to z square. So what is sin 2x? Sin 2x is 1 minus z square. So sin 2x is expressible in terms of new variable z. Now look, denominator root over sin 2x. So this is 1 minus z square. And sin x plus cos x into dx is dz. Now this one is standard one. So this is sin inverse z plus c. So put value of z. So sin inverse sin x minus cos x plus c. So this is number 1. Number 2. So dz by root over 1 minus z square sin inverse z plus c, sin inverse full value of z plus c. Look, sin x plus cos x, our main aim is to get sin x plus cos x. So we are putting sin x minus cos x equals to z. Now second option, you have to express sin 2x in terms of z. So put it in standard form and you get result. Next, second one, exactly same. So sin x minus cos x into dx. So derivative of cos x is sin x. So derivative of minus cos x is sin x. So sin x minus cos x equals to z. sin x plus cos x is z. So this is cos x and this is sin x equals to dz by dx. Now numerator is sin x minus cos x. So sin x minus cos x into dx equals to minus dz. So this is our main aim, to express numerator in terms of z. And second one is you have to express sin 1 cos x, whether it is possible to express sin x into cos x in terms of z. So taking square, 1 plus 2 sin x cos x equals to z square. So sin square x cos square 1. So sin x into cos x equals to z square minus 1 by 2, because here only sin x into cos x. Now this will be minus dz. Sin x minus cos x is minus dz. So z square minus 1 by 2 total root. So root 2 into dz by root over z square minus 1. So root 2 into log z plus root over z square minus 1 plus c. So putting value of z, we get solution, that is primitive. So these two problems are most important problem to solve 3, 4, 5 and 6. So look, problem number 3. So if you write it in terms of sin and cos, sin x cos x and this is cos x sin x, both are within root over this one. So if we take LCM, sin x into cos x and this is sin x plus cos x dx. So we have already solved this one. Sin x minus cos x equals to z. This is problem number 1. Only sin 2x, it is 2 sin x cos x. So we get integration of root over tan x plus cot x. Then problem number 4, same problem. So tan x is sin x by cos x minus cos x by sin x into dx. So this is sin x into cos x and this is sin x minus cos x dx. So this reduces to problem number 2. We have already solved this. So 1, 2, 3 and 4. Next, problem number 5. Root over cot x dx. So look, root over cot x, it can be written as cot x plus root cot x plus root tan x minus root tan x minus root cot x dx. So look, tan x cancel. This is 2, it is balanced by half. Now we can write it as sum of or difference of two integrand. So minus root over tan x minus root over cot x dx. So we have already solved this. This is problem number 3. We have already solved 4. So it is of root over cot x. And if it is root over tan x, we have to put here plus. So to solve root over cot x and root over tan x, you have to know how to solve root over tan x plus cot x and root over tan x minus cot x. So 3, 4, 5 and 6 most important for competitive exam also. Now we consider 4 more problems. Problem number 7, 8, 9, 10. Suppose problem number 8. dx by sine to the power 4x plus cos to the power 4x. Fourth degree equation. Now our main aim is to put it in standard form. We know if it is second degree in sine and cos, we multiply it by sec square x. It is of fourth degree, so we multiply it by sec to the power 4x dx. Now it is tan to the power 4x plus. Now if we put tan x equals to z, we know you have to put tan x equals to z. So sec square x dx equals to dz. So 1 sec square x is present. So we write it as 1 plus tan square x into sec square x. And denominator is of this form. 1 plus tan square sec square plus sec square. So meaning remaining same. So it is 1 plus z square by z to the power 4 plus 1 into dz. Now this one, you know the rule, try to recall. It is z square plus 1 by z to the power 4 plus 1. So it is of this form. Look, try to recall. X square plus 1 by x to the power 4 lambda x square plus 1 dx of this form. Because here this is z to the power 4 plus 1, here lambda equals to 0. So rule is, you know, you have to divide by x square. Then x minus 1 by x equals to z. So dividing by z square, this is z square plus 1 by z square dz. So this is 1 by 1 plus z square dz. And you have to put z minus 1 by z equals to p. Another transformation. Why? Because derivative of this, you look, you get the numerator. So that is why we are putting this equals to p. Now we express z square plus 1 by z square in terms of z minus 1 by z. So a square plus b square, a minus b whole square plus 2ab. So 2 into z into 1 by z. Now this is, numerator is dz and dp, this is dp, and this is p square plus 2. So this is well known standard integral. It is 1 by root 2 tan inverse p by root 2 plus c. So put value of p. So 1 by root 2 tan inverse. What is p? Z minus 1 by z plus c. Then put value of z also. Z equals to tan theta. So tan x minus cot x plus c. 1 by z, so 1 by tan is cot. So this one. Multiply numerator and denominator by sec square x. Then put tan x equals to z. Then it reduces to this integral. This is well known form. Divide by z square, then put z minus 1 by z equals to p. Now 7. So sine 2x, this is x. So try to express in terms of same angle. 2 sine x cos x dx by sine to the power 4x plus cos to the power 4x. Now it is of 4th degree. Multiply it by sec to the power 4x. So this is tan to the power 4x. So 1 sec square x, this is unchanged, and sec square x into 2 sin x cos x. So multiplying throughout by sec to the power 4x. You have to recall it. So if we simplify this, this is 2 tan x, 1 by cos. So tan and 1 cos is cancel out. Sec square x dx. Now put a transformation so that this integrand is transformed into standard form. Now 2 tan x sec square x, and it is tan to the power 4. To make it quadratic, we have to put tan square x equals to p. Tan square x. Now what is derivative of tan square x? 2 tan x into sec square x. So this is our advantage. So what is derivative? 2 tan x sec square x dx equals to dz. So this is dz by z square plus 1. So tan inverse z plus c. So what is z? Tan inverse. What is z? Tan square x plus c. So multiply by 6 to the power 4x dx. Then put tan square x equals to z. Now root over sec x minus 1, root over cos x minus cosec x minus 1. They are of same type. Root over sec x minus 1 dx. So it is 1 by cos minus 1 into dx. So root over 1 minus cos x by cos x dx. So root 2 sin x by 2. 1 minus cos x. 2 sin square x by 2. So root 2 sin x by 2 by root over cos x dx. So this one. We suppose that x is in first quadrant if no restriction is given. That is why we are taking only plus sign. Now derivative of cos x by 2 is sin x by 2. So express cos x in terms of cos x by 2. So 2 cos square x by 2 minus 1. This is formula of cos x. Cos 2x, 2 cos square x minus 1. So cos x equals to this, root 2 sin x by 2 dx. Then you put a transformation to make it standard form. So let root 2 cos x by 2 equals to z. So root 2 sin x by 2 with negative sign into half equals to dz by dx. So we are getting sin x by 2 dx. This is root 2 dz. Root 2, 1 root 2 is cancelled out, and this is root 2 dz with a negative sign. So this one is minus dz by root over z square minus 1. Now it is of standard form. So what is standard form? Log z plus root over z square minus 1 plus c. Put value of z. So this one exactly same. You solve it. So this is exactly same. Now we consider 4 more problem, 11, 12, 13, 14. So problem number 12. 12 root 2 dx, then sine alpha and root over, this is sine x, not sine alpha, alpha is constant, so cos c minus cos d, 2 sine d plus c by 2. So 2x plus alpha, so it will be x plus alpha into sine d minus c by 2. Alpha is cancelled. So this is sine x. Root 2 dx. So sine x, and this one is root 2. So this is 2. Sine x into formula of sine x plus alpha. Sine x cos alpha, cos x sine alpha. Now root 2 cancel. Now look, problem number 11 and 12 are same. Look, here it is sine x and it is sine qx. So if it is inside root over, it will be sine square and sine qx, and this is sine x plus alpha. So problem number 11 and 12 exactly same. Now dx by sine x, so 1 sine x is common, so this is sine square x within root over sine square x, so this is cos alpha plus cot x sine alpha. So we are getting sine, it is outside, sine square, so it will be cos x square x dx, root over cos alpha plus cot x sine alpha. So we are getting this one. Now look at the denominator. Cos alpha is 0, derivative of cos alpha is 0. Cot x, cos x square x, you are getting cos x square x, and it is sin x. So we have to put a transformation to make it standard form. So what is the transformation? Denominator is within root over, so cos alpha plus cot x sin alpha equals to z square, it is within root over. So minus cos x square x into sin alpha, 2z dz by dx. Here it is cos x square x, so cos x square x dx equals to 2z dz minus 2z dz by sin alpha, So we are getting value of cos x square x dx. So now put the integrand in terms of z. So integration minus 2z dz by sin alpha by root over z square, that is z. So minus 2 by sin alpha outside, so this is dz. Minus 2 by sin alpha outside, z cancel. So this one is standard form. So this is minus 2 by sin alpha into z plus c. So what is z? Minus 2 by sin alpha root over cos alpha plus sin alpha cot x plus c. So this is also most important problem for board as well as competitive exam. So 9 and 12, they are of same type. Next, 13. Sin x minus alpha by sin x plus alpha. So our main aim is to omit root over from numerator. So multiply it by sin x minus alpha. So balance it by sin x minus alpha and sin x plus alpha. This is already present. Alpha is obviously constant. This is sin square x minus sin square alpha. This one. And it is sin x cos alpha minus cos x sin alpha dx. So cos alpha is constant. Make it difference of two integrand. Sin square x minus sin square alpha. Sin alpha outside cos x dx by sin square x minus sin square alpha dx. Now whose derivative is sin x? Cos x. So put cos x equals to p. So sin x dx equals to minus dp. And sin x equals to q. So cos x dx equals to dq. Equals to dq. Now this problem reduces to cos alpha into minus dp by what is sin square? 1 minus cos square. So 1 minus p square minus sin square alpha. And this is sin alpha. This is dq by q square minus sin square alpha. This is q square with root over. So look it again. So minus sin alpha outside into dq by q square minus sin square alpha. Q square minus sin square alpha. Now this one minus cos alpha outside dp by 1 minus sin square alpha cos square alpha minus p square and minus sin alpha unchanged. So sin x minus alpha, formula is sin x minus alpha. Here it is minus, so it will be plus. So this is minus, so this is minus. Sin alpha by dq by q square minus sin square alpha. Now both are in standard form. So this is a square minus x square. So sin inverse p minus cos alpha sin inverse p by cos alpha. So this is p by cos alpha. And this is minus sin alpha log q plus q square minus sin square alpha plus c. So put value of p and q. You get result. So you have to omit root over from numerator. This is also a typical problem. Now last one. We have already solved this problem in previous class. Here it is cos alpha only. So dx by a plus b cos alpha. B is here cos alpha. So you know you have to express cos x in terms of tan x by 2. So 1 minus tan square x by 2, 1 plus tan square x by 2. So this is sec square x by 2 dx. So 1 plus tan square x by 2 minus cos alpha into 1 minus tan square x by 2. So tan x by 2 equals to p. So sec square x by 2 dx into half. So it will be at right hand side. So this is 2 dp. So half is to right hand side. Now this is 2 dp by 1 plus p square cos alpha into 1 minus p square. Now denominator is of quadratic. So 2 dp by 1 minus cos alpha. 1 minus cos alpha. 1 minus cos alpha. This is p square, p square. So p square into 1 plus cos alpha. So to make coefficient of p square as 1, we have to take 1 plus cos alpha common. This is p square 1 minus cos alpha into 1 plus cos alpha. Now use trigonometry. So this is 2 dp 1 plus cos alpha, 2 cos square alpha by 2. This is p square 2 cos square 2 sin square alpha by 2 by 2 cos square alpha by 2. So finally 1 by cos square alpha outside. So this is dp by p square plus tan square alpha by 2. This is of standard form. So what is the standard form? 1 by cos square alpha by 2. So 1 by a. So 1 by tan alpha by 2. Tan inverse p by tan alpha by 2 plus c. So this is final value. So you can simplify it. So sin by cos. So cos alpha by 2. So cos square alpha by 2 into sin alpha by 2, and this is tan inverse p cot. This is p cot alpha by 2 plus c. And this is 1 by sin alpha cos alpha tan inverse. What is p? Tan x by 2 into cot alpha by 2 plus c. So you can simplify it. 2 by sin alpha, 2 sin alpha by 2 cos alpha by 2 tan inverse tan x by 2 cot alpha by 2 plus c. So we have already solved this problem, but here it is cos alpha, so you have to use trigonometry. So today, through this video, I have solved some typical problem of integration of trigonometric functions. These are most important problems for competitive as well as board also. So thank you for today.